What's up guys, here Mr. G with another video for the grade 10. All this is to prepare for the upcoming exam. This time we're going to be solving a question on electrostatics, which is in the exams. It is a very important topic also for grade 11s and grade 12. But before that, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. Without saying more, we're going to see this question. The question was done in the Northern Cape in 2013. It was a set A for paper 1. Now the question says two identical objects P and Q are isolated stand which with charges of negative 6 times 10 to the minus 3 coulomb, which is charge P or object P, and positive 2 times 10 to the negative 3 coulomb, which is an object R, are brought into contact with each other. They move away again without touching anything else. Take the principle of conservation of charge. And this principle states that the total charge is conserved in an isolated system. That's all you have to say, guys. Now calculate the new charge on each object after they have moved away from each other. So in this case, we do have to apply this law of conservation of charge. So to do that one here, 7.2, we need to know that the new charge is going to be equal to the addition of charge P plus charge R divided by 2. And when you substitute, this one is a straightforward calculation. You'd have that is negative 6 times 10 to the minus 3, be careful with this one, plus positive 2 times 10 to the minus 3. Guys, in this formula you do have to substitute the sign. So when you do that calculation, you will get that the new charge on each sphere will be a negative 2 times 10 to the minus 3 coulombs. That is very simple. It means that each sphere will have a charge of negative 2 times 10 to the minus 3 coulomb. Answer the following question with regard to the movement of P and R make contact. When P and R make contact, what particles are transferred during contact? Write down only protons, electrons, or neutrons. And this one is very simple. You need to know that electrons are the ones that are going to move or transfer during this contact process here. The electrons are the one that move. In what direction did the particles that mentioned, in this case we're talking about the electron, move? Just write from P to R or R to P. Guys, they are going to move always from the more negative to the more positive. So in this case, the electrons were moving from P to R. The electrons were moved that when the two objects were in contact with each other. Electrons move in that direction, guys. So you must know that it is going to move from the more negative, in this case is negative 6, to the more positive, which is positive 2. All right, so it's going to be from a P to R. From P to R, that is the answer for that question. That is very simple. The next question, calculate the magnitude of the charge of the change in charge P. Now for charge P, they want charge P. We know now this one is question 7.4. We can do it here. It is enough space because it's quite small. You need to know that change in charge, like all the changes in physics, is going to be final charge minus initial charge. And we are talking about P. All right, so let's mark this one. We're working with P. The final charge of P is going to be negative 2 times 10 to the minus 3 minus the initial charge of P is minus 6 times 10 to the minus 3. Guys, it's very simple. I hope you are following me. I hope you understand what I'm doing here. So the change in charge is going to be equal to 4 times 10 to the minus, let's fix that 10, is not well, times 10 to the minus 3 coulomb. Guys, it's really simple. All you need to know that the change in charge is always going to be final minus initial, and the final one is the new charge you calculate. Be careful, don't you make a mistake there. This one is the final charge that each of the spheres will have, and calculate how many of the particles were transferred between P and Q during the contact process. Now for this one, guys, we have to quickly go to the formulas. I want you to see something here. First of all, here is the charge of the electron which we are going to use. This one is the charge of the electron, is going to be given to you. Important to remember that you have it here. And then in this topic that say electricity and magnetism, there is a formula which is this one here that is going to help you to calculate the number of electrons that was transferred during this physical process. Note the following: if any of the higher grades is watching this video is quite important for the grade 11 and the grade 10. So it's not just the grade 11 and the grade 12, it's not just grade 11. So in this case, charge is going to be equal to the number of electron multiplied by the charge of one electron. We are looking for the number of electron. Now this one, because it's the number of electron during contact, during the process, this is important, this number of electron during the process. Therefore, the charge we are going to substitute here is the change in charge. Now I want you to know that if the number of electrons you are looking is the number of electrons that were transferred during the contact process, then the charge you are going to be calculating is going to be the change in charge. So this one here is quite important. So I hope you understand. But now if we substitute, we have the change in charge to be a positive 4 times 10 to the minus 3. So this one is going to be a positive 4 times 10 to the minus 3. And this is equal to the number of electrons multiplied by the elementary charge. In this case, is going to be 1,6 times 10 to the negative 90. Now, I want you to also note something. This final answer of the number of electrons we are looking must be a positive answer. It cannot be negative, guys. So make sure the final answer is positive. You can manipulate the numbers here so you can get a positive answer. For instance, if you substitute a minus here, you will get a negative answer. But then don't let that one to be the final answer of the question. Then the number of electrons is going to be, let's write this one here, just NE, is going to be equal to 2,5 times 10 to the 16 electrons. So this is the answer. I hope you understand. It's quite simple and it's a very important question that you can practice for the exams. Not only grade 10s, but the grade 11s and the grade 12 as well. So thank you for watching, guys. If you think it helps, subscribe for the channel, thumb up, and I'll see you next time. Mr. G here.